Welcome, this is the video for type 1 and type 2 error and also power. So it's page 14 in your notes. This part is not in your notes, but before we begin, I wanted to go over a scenario real quick. So void of statistics, just talking in general. I mean, I threw in a few statistics word, but so as you can read here, here's the scenario. I'm babysitting my niece and nephews right here, and I'm helping them get ready for bed. And they're kind of wild, right? So, I mean, I tell my niece to go brush her teeth, and she comes back, and there's two possible truths, right? Either she brushed her teeth, or she did not. So we're going to say the null hypothesis will be that she brushed, alternative will be that she did not brush. So why would the null hypothesis, why would we assume that that's true? Well, my sister makes them do it every night, so I'm assuming that they have the habit. But also, what if my niece felt the freedom of her mom not there and decided to continue playing while I was taking care of the boys, right? So she could have told me that she brushed her teeth when she did not. And I'm going to assume that the null's true. Why wouldn't I trust her, right? But if I assume that the null's true and she did not brush her teeth, obviously I made an error. This is called a type 2 error. I did not reject the null hypothesis when the null hypothesis was actually false, right? So the null hypothesis was that she brushed her teeth, I assumed that was true. She did not. Type 2 error. So is there another error that I could have made in this scenario? So kind of think about that. So what if what if I said, come on, right? I don't think you did it, right? I saw you playing in your room. So what if I said, I don't think you brushed your teeth, but she really did. So the null was true. She did brush her teeth, but I rejected the null. When this happens, it's called a type 1 error. All right, so we have type 1, we have type 2. So what evidence would I maybe have that would lead me to think that she did not brush her teeth? So, I don't know, think to when you're a kid or something like that. Why would I think she didn't? Well, kids like to play, right? Brushing teeth's not that fun for most kids, right? So there's definitely evidence there. So a chance that I could make a type 1 error where, I'm kind of saying, you know what? I don't think that null is true. I don't think you brushed your teeth, okay? But really it was true, so I rejected it when it was true. So kind of think of the consequences of this error, of these errors. If she tells me she brushes them, so back to the type 2 error, if I assume she brushed but she did not, she could get cavities, right? So that's one of the consequences. Another consequence, what if, I say, you know what, I don't think you brushed your teeth when she really did. She might not trust me, like, kind of annoying that I'm calling her a liar, basically, right? All right, so what I want you guys to do, think of that scenario, and I want you to pause this video, and these instructions were kind of in Canvas, but I suggest that you pause this video and do this paper right here. So this is kind of void of statistics, just thinking of type 1 and type 2 error. So you'll look through this. There's a couple of scenarios, and think about those. So just to go back, wrong document. A type 2 error is not rejecting the null hypothesis when the null was false. And type 1, so let me write it here real quick so you can see it, and then you can work on that paper. So type 1 error is when the null is true, but we reject it. It's true, but we reject it. Type 2 error is the alternative was true, and we failed to reject the null. So so the alternative was true, but we went with the null, right? So, like I said, pause this video, do all these scenarios. There's a key there, you can check it, and then I suggest you come back to this video. I think this lesson will make a lot more sense. So I wanted to start you off with the scenario about brushing the teeth, just to kind of put it in perspective. I go through these, no statistics, just straight up thinking about these errors. So yeah, give that a try, and then come back here. All right, so hopefully you did well on that practice real quick, and you saw the key there. So at the top of this paper, we're going to write, so that we can find it again, type 1 error. So remember, we always write the null first and the alternative second. Null first, alternative second. So a type 1 error, the first error, type 1 error, is that the null is true, but we reject it. And type 2, which we usually write the alternative second, right? So second, alternative second, is that the alternative is true, but we fail to reject the null. Okay, so that's the definition of type 1 and type 2 errors. And hopefully you feel a little bit more comfortable after doing those scenarios. So right here we have, this really happened a couple years ago. There was this shoe company called the Wolverine Worldwide. They produce shoes, and they improperly disposed of chemicals, and they leaked into the groundwater. The state of Michigan has a policy that if 7% of households in a city exceed the safe limit, then the city needs to switch to bottled water. So maybe you heard also Flint, Michigan had to do bottled water for a while, so Michigan's kind of had a little bad luck with their water in recent years. So for this specific scenario, though, a concerned citizen takes a random sample of 100 households and finds 12 to be unsafe. So they have a statistic here, right? And it's at 12% of the houses are unsafe. Do we have evidence that Rockford should switch to bottled water? So again, I suggest you pause this. Think of our null hypothesis, think of all our alternative hypothesis. I suggest you go through this paper and then check that it's true. What you did was true. Okay, so our null. Our null is that, I'm going to put it, our null is that the true proportion of houses that have unsafe water is at 7%, right? So our null is saying, you know what, that sample just happened by chance. We don't need to be alarmed. There's nothing fishy going on. You know what? That claim that they should be about 7%, that's probably true. Okay? And so just in words, we're saying the water is safe. Now the alternative, because we have that evidence, we're going to say, I don't know. I think that our true proportion of houses that have unsafe water is actually greater than 7%. And so what we're saying here is that the water is unsafe. Okay, so don't forget our P is going to be the true proportion of all households in this town of Rockford with unsafe water. Okay, so I didn't, but this concerned citizen conducted a significance test and they got a p-value of 0.025. So let's make sure that we remember what a p-value is. So remember, they have the null, they had the alternative, they assumed the null conditions were true, and they tested what's the probability that that could have happened by chance, that we could have got a sample with 12% having unsafe water. So interpreting that. Assuming the null was true, meaning our true proportion of unsafe water in the households is 7%, there is a 0.025 probability of getting a p-hat of 12% or greater by chance. Okay. So, are we going to reject the null or fail to reject the null? So kind of think about that, what our p-value was. Did it say anything about a significance level? Yeah, it did, right? Ooh, that transferred. It was supposed to be that symbol, so I guess when I changed it to a PDF, it didn't work very good. Alright, so reject the null or fail to reject the null. Well, notice our significance level is greater than 0.025. So because 0.025 is less than 5%, we reject the null. Okay? Alright, so pause right there for a second. We're going to finish this up. Okay, so reject the null, fail to reject the null. Kind of think about that, where we're headed, right? Alright, so because 0.025 is less than 5%, we reject the null, and Rockford should start drinking bottled water, right? We're rejecting the null, we're going with the alternative. Rockford should drink bottled water. Okay, so let's suppose this decision is wrong, right? This decision that we just made in B. What would be the consequence of this error? Well, they'll spend money on bottled water when they could have drinking from the tap, right? Which is a lot cheaper and save a lot of bottled water, right? Save a lot of those plastic bottles. So like I pointed out, this is a type 1 error right here. Okay? So we rejected the null, but it was true. The water was safe. Okay? So if the water is safe, which I'm saying that it was because the decision was wrong, what is the probability that we're going to make this error? So kind of think about it. What's the probability that we'll reject the null? Well, think of our significance level. So we could get almost any p-value, right? And so kind of think, what's the probability that we're going to get a p-value less than 5%? Well, hopefully you thought, well, we have a 5% chance, right? So kind of thinking of all the p-values we could get from 0 to 100, there's a 5% chance that we are going to reject the null. So we do have a 5% chance, so the probability of a type 1 error is equal to alpha, whatever your significance level is, because that's when you'll reject it. Alright, so look at 34. Now suppose that our p-value is actually 0.217. So the probability, think of what our p-value means again. So it's the probability that we would get this statistic right here, right? That this person, the 12 out of 100, that, you know what, there's not really 12%, right? You just found this sample randomly by chance, you know, there was only 7%, but in your sample you got 12, right? So remember, our p-value is the probability that we got that sample by chance. So if we did just get that sample purely by chance and there's nothing wrong with the water, there's a 21% chance that that could happen. Now, because that's bigger than 5%, what are we going to do? We fail to reject the null. Guess what, Rockford? You don't need to go buy bottled water, right? Well, Rockford should keep current water. Okay. Now again, suppose this decision that we made right here, we failed to reject the null, so we went with the null, but the alternative was true, right? That decision's wrong. This is going to be a type 2 error. What are the consequences of going with the null, right? Saying, you know what, the water's safe, you're fine. But really, the water was unsafe. What are the consequences, right? All right, so people will drink the water because we told them it was safe, so people could get sick, potentially die. Okay? Hopefully not, but I mean, it is a possibility. So think about this. Are the consequences in question number 2 or number 3? Whoa, number 2? I think I changed my numbering here, right? So let's change that real quick. 33 or 34. So basically, is a type 1 or type 2 error more serious in this case? Well, probably type 2, right, in this situation. All right, so there you have it. That is type 1 and type 2 error. So let's go through this activity real quick. So Mr. Jones purchased a trick coin that is supposed to land heads 70% of the time. One of his students volunteers to test this claim. He flips it 50 times, and it lands 35 times on heads, right? So the student then performs a test following these hypotheses at a significance level of 10%. So kind of think about this. If our null hypothesis is that, you know what, 75%, it will land 75%. He just got a random sample, right? So this is saying the coin works as advertised. Now the null is saying the coin does not work. It's landing on heads less than 75% of the time. Coin, wow, does not work as advertised. Okay, so remember, P is the true proportion of tosses of this coin that would land heads up. So, type 1 error. Remember, type 1 error is, so kind of think about it, we usually write the null first. So it's when the null is true, right? So kind of think about it. The null is true, but we reject it. Type 1 error. We always write the null first and then the alternative second. So type 1 error, the null is true, but we reject the null. So type 1 error. The coin works as advertised. But, and it's not our fault, we didn't do bad statistics, right? So the true P is 75%, but we found convincing evidence that the coin is not working. So kind of think how that could happen, right? Okay, so P is, oops, wrong thing. P is less than 0.75. How could we get evidence, right, when it really was true? Kind of think of that. Okay, type 2 error. The coin does not work as advertised. But the student doesn't find convincing evidence that the coin is not working. All right, so again, type 2 error, remember, the alternative was true, but we failed to reject the null, so we went with the null. Okay, so kind of read through that, think about it. Which type of error may result if in Mr. Jones returning the coin and writing a negative review? So why would he return the coin? Right? So he returns the coin. So kind of think about it. He returns the coin because he rejected the null, right? So if he fails to reject the null, he's going to keep the coin because it works as advertised. So here we have a type 1 error. Think about that. Why? Because Mr. Jones returns the coin. He thinks it doesn't work. He rejected the null. But what? But it was working. He returned it, but it was working. He thought it didn't. He gave him a bad review. It really was working. Okay. All right, so if the students were to use a 5% instead of a 10%, would this make it more or less likely to reject the null? Right, so if we use an alpha, a significance level of 5%, there's a 5% chance that we'll commit a type 1 error. So if we reject the null when the null is true, we committed a type 1 error. Memorize that. Okay, but reducing our alpha will make will make a type 1 error less likely. Okay, great. Okay, so pause right there for a second. Make sure that you're feeling good about type 1, type 2 error, because we're about to go on, okay? Now, you can find more information in your book, of course. You can email me if you have more questions. We can set up a Google Meet. We can chat about it. But the next thing that we're going to talk about is power. Now, this is an important concept in statistics. We're not actually going to calculate power. You'll always be given to you. It's not a entry-level statistics class concept. So we will not be finding that. So remember that I claimed that I was an 80% free throw shooter. Mr. Jones across the hall is skeptical and believes that I am less than 80%. So I decided to take another simple random sample of free throws to prove myself. So we're going to, we did this at the beginning, we're going to kind of do it again. So my P is the true proportion of free throws that I'll make. Okay, not in a single sample, but it's going to be my true proportion. My body mechanics all working together. Like, how often am I going to make that? What's my true free throw percentage? So remember, our null is at 80%. And if the null is true, then I'm being truthful, right? So just kind of putting that into words. I told you I was 80%, and I am. Alternatively, though, if you remember, based on evidence, we think that the P is probably less than 80%. And so if this happened, I'd be exaggerating if the alternative was true. Okay, so a type 2 error. Think about the type 2 error. So type 1 goes with the null. Type 2 error, Miss Buse, is less. So type 2, we're going with the alternative. The alternative is true. Miss Buse is less than an 80% free throw shooter. But guess what? We failed to reject the null. So I actually am lower than 80%, but we went with the null. Okay? Okay, so type 2 error. So I want you to kind of think back. Type 1 error, we pointed out, not here, but here. Type 1 error, we know the probability that we'll commit a type 1 error. So power actually has to do, and don't get these mixed up, but power has to do with type 2 error. So we're going to look at that in a second. So suppose Miss Buse's free throw percentage is actually 66%. The alternative was true this whole time, okay? We're going to enter all the information into an applet, and then we're going to look at our type 2 error and just kind of see that. So it's supposed to go to this link, but obviously it's not. So we'll get that up in a second. Oh, there it goes. Sweet. All right, so you can go to this if you'd like to as well and kind of see what's going on. So the null hypothesis, right? So think about our null hypothesis. It was over here at 80%. And so if you remember, the alternative hypothesis was not two-sided. We did less than, if you remember. And we're going to look at a type 2 error. All right, so the true value of our P, I'm actually a 66% free throw shooter. All right, sample size, I shot 50, and we're going to look at a 5% significance level. The type 1 error, right, as you see right there. Okay, so what are these two graphs? All right, so if you remember, the null, I mean, we did a significance test, errors and significance test. We did the significance test based on this green, right? So everything we imagined was going on in this green, but really my true P was 66%. Now this is why power, we don't calculate in this class, because to actually calculate it correctly, you do need the alternative, the true alternative, which most of the time you won't have, so we're not going to calculate that. But I want you to kind of look at this overlap, okay? So look at where they cross. Think about what this blue part is. Just kind of think about that, right? So the red is the null hypothesis, right? Green's what's really happening. So the null hypothesis, if you remember, I got pretty low, okay? So the true sample came from this green guy. So really kind of think about this, analyze it a little bit. I want you to just notice real quick what happens as I increase my sample size. Okay, that overlap. And also what happens as I let let's go up to 8%, 10%. Kind of take a look at that, okay? So what if I go down to 1%? Can kind of see what's going on there, okay? Let's take my sample size back down and just kind of look at that again at 10%, right? At 0.1%, we'll do 0.15, 5%. So this white line you can kind of see is moving around. So up here, probability of type 1 error is 5%. Probability of type 2 error is 20%. Okay? All right, so going back to what we did, we had a sample size of 50, and we had an error of 5%. So I want you to take a look at the type 2 error. Okay, so again, we don't actually calculate this. The power is 76%, probability of a type 2 error is 24%. So just kind of look at that and see what's going on. Okay, so remember, again, the red is what we assumed. That's where we got our p-value from. That's what we did all our math from. This green is actually the truth, okay? And so, if you remember, if we got a p hat really low, okay, just kind of notice where it's falling in place of that red and that green. All right. So let's talk about what we just saw. Okay, if the alternative is true, what's the probability of a type 2 error? So it told us that we had a 24% probability. So I want you to kind of think about that. If we take 1 minus the power, we're going to get that right there. So write that on your paper. If the null is true, what would be the probability of a good decision here? Well, 76%, right? So think about that and that relationship there. We're going to interpret the probability of this good decision. So kind of interpret what we just saw. So if I am a 66% free throw shooter, which I am, there is 76% probability that we decided correctly that I'm exaggerating. Yeah. Okay, so we're going to look at that one more time. Alright, why are you disconnecting? Okay, so hopefully, gosh, sorry about that. Let's go back up to our 80%. That was at 5%, stay there. Less, right? And value of P was at 66. Size, okay, everything else is good. Okay, so, we want to show type 2 error and power. Alright, so the alternative hypothesis, the null hypothesis, these would have been the sampling distributions for either one. Remember, we assumed the null was true, so we found our p-value from that null, and so there's a probability that we would have some error there, right? Probability that we did commit a type 2 error was 24%. So I want you to kind of look at that green, think of that 24%. The power is the 76% there. Okay? All right. So, boom. What did we just look at? Well, it is a little bit more complicated math for what we're doing, but visually you can see, right? We assumed the null was true when it really wasn't, but we didn't know, right? And so comparing those sampling distributions, we were finding the probability based on that red. Okay, now that red was obviously not the truth, and so, you know, if we picked a p hat in the bottom, yeah, it would have lined up, right? And so we do have that error, okay? All right. So let's talk about this a little bit more. So if you notice, we clicked on display power and we wanted to increase the power of our test. Well, what the heck is power? Whatever it is, we can increase it if we increase our sample size, okay? And whatever power is, we can increase it if we increase our alpha. And we can increase it if we decrease our p, and that's going to increase our distance from the null. Okay, so what is power? Power is the probability that we reject the null given that the alternative is true. Okay, so let's look at a few statements real quick. So you might want to write these down on that part of our notes that we're on right now. There are a few things that do describe power. Power is the probability of rejecting the null hypothesis when it is false, right? So if we reject the null, we go with the alternative. This is a correct choice, right? So it's the probability that we reject the null when it needed to be rejected, right? Power is the probability of making that correct decision, like I said. Power is the probability that a test of significance will pick up on an effect that is present. So for example, the effect that we looked at earlier was that the water, if you remember, the Rockford Wolverine Shoe Company, if we found out that, yeah, this water's unsafe, that's picking up on this effect, okay? So the probability that we detect that. So the power's a good thing, right? Power is the probability that a test of significance will detect a deviation from the null hypothesis. Should that deviation exist, it's the probability of avoiding a type 2 error. So probability is the probability of not making a type 2 error, okay? But basically, this is maybe one of my favorite ones. Power is the probability of making a correct decision. We reject the null hypothesis when it was untrue. All right, so write this real quick. Probability of a type 2, this was supposed to say power, sorry. Probability of a type 2 error is 1 minus our power. Okay, and so hopefully you saw that there, right? So what is the probability of a type 2 error? It was 1 minus power. This was our power. The probability of making a correct decision. So probability of making a bad decision, a type 2 error, is 1 minus power, 24%. All right, so let's look at it in another example. So let's say that we had a statistics major and a finance major decide to get married. In order to investigate their per-person expenses for the wedding, they select a random sample of guests they have invited and then ask them, are you coming or not? So based on their sample, they decide to do a test. Their null hypothesis is that 75% of the guests are going to attend. I don't know where they got this claim from, but they got it, okay? They're going to do a two-sided test where they're going to try to test the true proportion of all guests that will attend the wedding. Okay, A says the power of the test. And on the AP test, you'll be given the power. It'll tell you. The power to reject, the power of the test to reject the null when P equals 0.75, or equals 0.7. So when we make a correct decision is 10%. We're going to interpret this value. So if the true proportion of guests that will attend the wedding is 70%, there is a 10% probability that they find convincing evidence to reject the null. So read through that again, think about it, let that kind of sink in. All right, so we're going to find the probability of type 1 error. Remember, probability of a type 1 error, type 1 has to do with the null, right? Because we write the null first, so type 1 has to do with the null. That means we go with the null, right? But what? The null wasn't true, right? So we go with the null. The null was true. Sorry. I said that wrong. Sorry. A type 1 error is when the null is true. So remember, we write the null first. Type 1 error is the null is true, but we rejected it. So the probability that we reject it is that 5%. So that's the probability. So the probability of a type 1 error is our alpha. So 5%. The probability of a type 2 error is 1 minus power, because power is the probability that we make a correct decision in this case. So that will be 1 minus 0.1, which is 0.9. Okay, so remember, as if we use a lower one, so as we decrease our alpha level, it's going to make it harder to reject the null. So what's going to happen? The power would decrease. Alright, so if we use n equals 100 instead of n equals 25, so we have a higher sample size. Whenever you increase your sample size, you're going to increase your power. So the better sample size you have, the more accurate usually your estimates will be. So our power would increase because our variability got smaller, right? And so if you kind of think about that will work. All right, that's it for today. Again, let me know if you have any questions. But bottom line, what you need to know, power is the probability of making a correct decision. We reject the null when the null is false. All right, good luck on type 1, type 2 error and power. Reference the book, do the practice problems, and then take that quiz.